Hello children, in this video we are going to learn about the applications of eddy current, induction stove, eddy current brake, eddy current testing and electromagnetic damping. Before going to the individual application, you must know certain things children, that is in each application what is the source of the magnetic flux. Change in magnetic flux is produced by the source. And the magnetic flux is linked to whether it is linked to the metal plate or a metal cylinder or a metal disc. That you have to get an idea about that. Then the eddy current, you have to check whether the eddy current is produced in that metal, and the effects of eddy current, either one of the cases you have to apply. Heat or eddy current produces heating effect, and also it will oppose the motion of the cylinder or metal disc. You have to apply one of the effect. And the next thing you should know that magnetic flux can be produced by a permanent magnet or by alternating current. This alternating current produces alternating magnetic field. The source of the magnetic field must be either one of these. Right, and you try to answer these 4 questions so that you can get a clear idea about that application. So first you should check whether the source of the changing magnetic flux is available or not, then the metal is available or not, and the eddy current is produced in that metal, and the effect which we are going to use, whether the heating effect or the effect that opposes the motion of the metal. You have to answer, and you have to answer these 4 questions children. Right, we will go to the induction stove first. Induction stove, first application is the induction stove. Now for that you refer this diagram. Each one of you might have this induction stove at your home. This is the cooking zone. Beneath this is the tightly wound insulated coil. Right, the magnetic flux, changing magnetic flux you need, that is applied to this coil. Where will you get this changing magnetic flux? That is the alternating current of frequency 20 to 40 kilohertz is applied to this coil, which produces the high frequency magnetic field. Right, what is this alternating current? You know that for the domestic purpose for your house, government provides 220 to 230 volt power supply, AC power supply with frequency 50 to 60 hertz. What I mean is, if you consider this as the one cycle, this is one cycle, you can see in 1 second there will be 60 such AC alternating current cycle will be produced in 1 second, that we call it as 60. Now 40,000, 20,000 to 40,000 alternating current cycle should be produced for this application of this induction stove. So this high frequency alternating current is passed to this coil, which produces, if this alternating current, it has to be linked to this cooking pan. Right, cooking pan is kept on the cooking zone, and this is the cooking pan of suitable material is used here. So such a high alternating current is passed, high frequency magnetic field is produced, is linked to this pan, which in turn produces eddy current. So you know that eddy current produces heat and the food will be cooked. Right, now we will quickly recollect what is given here. You can pause the video and note down. Cooking zone has tightly wound coil. Alternating current of frequency 20 to 40 kilohertz is passed to the coil. High frequency magnetic field linked to the cooking pan of suitable material. Eddy current is produced in the pan. Heat is generated. Food is cooked quickly, safely and economically. Right. Now you try to answer these questions children. Changing magnetic flux is produced by the alternating current of, hence the alternating magnetic field is got. So metal used is the cooking pan, eddy current is produced in the cooking pan, and the effect produced due to the eddy current is heat. Shall we pass on to the next application, that is the eddy current brake, that is the linear brake. It is used in linear brake, high speed trains and roller coaster, linear brake is used. Right, so electromagnet is fixed above the rail. You can see the electromagnet is attached to the train wheel. Right, so when when train is to be stopped, what has to be done? Switch on the electromagnet. High frequency magnetic field is linked to the wheel, right? This produces magnetic field that is linked to the wheel. So eddy current will be developed in the wheel. Eddy current will it will oppose the motion of the wheel, so the train stops. Next is the circular brake. Here you can see that the circular disc, it is rotating between the poles of the electromagnet. The circular disc and the train wheels are all attached with the through a shaft. Okay. Now as this rotates, circular disc rotates, as the wheel rotates, circular disc also rotates. So this is rotating in between the poles of the electromagnet. So when train is to be stopped, you switch on the electromagnet. Eddy current will be produced in this circular disc, rotating circular disc. Eddy current is produced. Eddy current, it will oppose the motion of the disc. The disc stops rotating, hence the wheel also stops rotating, right? So disc rotate between the poles of the electromagnet. When the train is stopped, switch on electromagnet. High frequency magnetic field is linked to the circular disc. Eddy current is produced in the disc, opposes the motion of the disc. Disc stops rotating, hence the wheel also stops rotating. Now we will answer those 4 questions, children. Change in the magnetic field is produced by the electromagnet. So the metal used here is wheel, and the second case it is the circular disc. Eddy current is also produced in the same, and the effect of eddy current is it will oppose the motion of the disc and the wheel, right? Now we will pass on to the next application, that is eddy current testing. It is the non-destructive method, and it is used to find the defects like crack, air bubbles in the material. You can see a surface, metal surface. You have to check whether this is the testing surface. You have to check whether there is a air crack or a hole in this, right? So for that, what you will do is alternating current is connected to this coil. Now this alternating current will produce the high frequency magnetic field. This high frequency magnetic field is linked to the metal surface, testing surface. So what happened? Eddy current is developed in this. So this represent the magnetic field produced by the eddy current. This is the magnetic field produced by the alternating current, magnetic field produced by the eddy current. So eddy current will be produced. If there is no defect, means eddy current will be having, if you record this eddy current with the help of a micrometer, current will be maximum and the shape of the eddy current is concentric circles, right? If there is a crack in the metal surface like this, the shape of the eddy current will vary, and also the current recording, micrometer current recording, it will also decrease, right? Now you can see the micrometer is connected to the voltage source, and the voltage source is connected to the AC coil. So this is the testing, this is the surface to be tested. If you pass this cylinder into this coil like this, no defect in this area, so you can see the eddy current and maximum current is recorded. Here you can see the defect, so in that case the eddy current value will reduced, right children? So you can note down this, pause the video, note down this. It is a non-destructive method to find the defect, cracks, air bubbles in material. High frequency alternating current produces high frequency magnetic field. This high frequency magnetic field produces eddy current in the testing surface. If there is a crack, amplitude and phase of the eddy current will change. You have to note down this. That is, the magnitude of the eddy current will reduce, and the shape of the eddy current will also be changed, right? So we will answer these 4 questions. Change in magnetic flux is produced by the alternating current, and hence the alternating magnetic field you get. The metal is the testing metal surface. Eddy current is also produced on the metal surface. The what effect do you observe? The amplitude, eddy current amplitude will change, and also phase of the eddy current will also change. And the last application is the electromagnetic damping. The armature coil, you can see armature coil is wound on a soft iron cylinder. Armature coil wound on a soft iron cylinder. This coil is suspended, and it is rotated between the radial magnetic field. As the coil rotates, magnetic field linked with the cylinder will also vary. So magnetic flux linked with the cylinder, soft iron cylinder varies means eddy current will be developed in this. So eddy current, it will oppose the motion of the cylinder, and you will get the steady steady deflection. You can note down the reading in the galvanometer, right children? Now the armature coil is wound on the soft iron cylinder. Coil rotates in radial magnetic field. Electric current is developed in the cylinder, produces damping force. Oscillation of the coil stops immediately and shows steady deflection. This is called electromagnetic damping, right? Shall we try to answer this 4 questions, children? What will you say? Change in magnetic flux is produced by, in this case, change in magnetic field. For this you take down this question. Change in magnetic flux is produced by the radial magnetic field. Metal is the soft iron cylinder, so eddy current is also developed in the soft iron cylinder. What effect is produced in damping, children? Electromagnetic damping. The soft iron cylinder, motion of the soft iron cylinder stops, right? I hope you understood, children. This is a detailed answer. Thank you.